Hey, y'all, welcome back. Today we're diving into C++ Chapter 11, and it's all about pointers, classes, virtual functions, and abstract classes. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. Let's look at inheritance. Suppose that you want to design the class part-time employee to implement and process the characteristics of a part-time employee. The main features associated with a part-time employee are the name, pay rate, and number of hours worked. Every part-time employee is a person. Therefore, rather than design the class part-time employee from scratch, we want to be able to extend the definition of the class person type from example 10 by adding additional members, data, and/or functions. When no member access specifier is included in a derived class header definition, it is assumed to be a private inheritance. Of course, we do not want to make the necessary changes directly to the class person type. That is, edit the class person type and add and/or delete members. In fact, we want to create the class part-time employee without making any physical changes to the class person type by adding only the members that are necessary. For example, because the class person type already has members to store the first name and last name, we will not include any such members in the class part-time employee. In fact, these member variables will be inherited from the class person type. To avoid multiple inclusions of header files in a program, ifndef, define, indef, the class of stream is directly derived from the class awstream. The class clock type has 3 member variables to store the hours, minutes, and seconds. Certain applications, in addition to the hours, minutes, and seconds, might also require us to store the time zone. In this case, we would like to extend the definition of the class clock type and create the class xclock type to accommodate this new information. That is, we want to derive the class xclock type by adding a member variable, say time zone, and the necessary member functions to manipulate the time. In C++, the mechanism that allows us to accomplish this task is the principle of inheritance. Inheritance is an is-a relationship. For instance, every employee is a person. If a derived class overrides a public member function of the base class, you can call the base class function by using the base class name, followed by the scope resolution operator, followed by the function name and appropriate parameter list. Derived classes inherit the properties of base classes. Inheritance lets us create new classes from existing classes. The new classes that we create from the existing classes are called the derived classes. The existing classes are called the base classes. The derived classes inherit the properties of the base classes. So rather than create completely new classes from scratch, we can take advantage of inheritance and reduce software development complexity. The derived class can redefine the public member functions of the base class. Now that we covered inheritance, let's dive into our next topic, right after this. Suppose that a class-derived class is derived from the class base class. Further assume that both derived class and base class have some member variables. It then follows that the member variables of the class-derived class are its own member variables, together with the member variables of base class. Suppose that base class contains a function, print, that prints the values of the member variables of base class. Now derived class contains member variables in addition to the member variables inherited from base class. Suppose that you want to include a function that prints the values of the member variables of derived class. You can give any name to this function. However, in the class-derived class, you can also name this function print, the same name used by base class. This is called redefining or overriding the member function of the base class. To redefine a public member function of a base class in the derived class, the corresponding function in the derived class must have the same name, number, and types of parameters. In other words, the name of the function being redefined in the derived class must have the same name and the same set of parameters. If the corresponding functions in the base class and the derived class have the same name but different sets of parameters, then this is function overloading in the derived class, which is also allowed. Now let's talk about constructors of derived and based classes. A derived class can have its own private member variables, so a derived class can explicitly include its own constructors to initialize them. When we declare a derived class object, this object inherits the members of the base class, but the derived class object cannot directly access the private data members of the base class. The same is true for the member functions of a derived class. That is, the member functions of a derived class cannot directly access the private members of the base class. As a consequence, the constructors of a derived class can directly initialize only the public data members inherited from the base class of the derived class. Thus, when a derived class object is declared, it must also trigger the execution of one of the base class's constructors. Furthermore, this triggering of the base class's constructor is specified in the heading of the definition of a derived class constructor. First, let us write the definition of the default constructor of the class box type. Recall that if a class contains a default constructor and no values are specified when the object is declared, the default constructor executes and initializes the object. Because the class rectangle type contains the default constructor, we do not specify any constructor of the base class when writing the definition of the default constructor of the class box type. So there you have it, constructors of derived and base classes in a nutshell. Now let's move on to our next topic, right after this. Recall from Chapter 10 that a class can have a destructor. As we will see in the next chapter, destructors are typically used to deallocate dynamic memory allocated to the objects of a class. A memory space that is allocated during execution time is called a dynamic memory space. The next chapter explains how to create and work with dynamic memory. Suppose that a base class and its derived class have destructors. When a derived class object goes out of scope, it automatically invokes its destructor. When the destructor of the derived class executes, it automatically invokes the destructor of the base class. So, when writing the definition of the destructor of the derived class, an explicit call to the destructor of the base class is not needed. Furthermore, when the destructor of the derived class executes, it executes its own code first, and then calls the destructor of the base class. For example, suppose that class 3 is derived from class 2, class 2 is derived from class 1, and these classes have destructors. When an object of class 3 goes out of scope, first the destructor of class 3 executes, then the destructor of class 2 executes, and finally the destructor of class 1 executes. That is, the destructors execute in the reverse order. The previous section explained how to derive new classes from previously defined classes. Recall that to include a system-provided header file such as IOStream in a user program, you enclose the header file between angular brackets. To include a user-defined header file in a program, you enclose the header file between double quotation marks. Now composition. Composition, aggregation, is another way to relate two classes. In composition, aggregation, one or more members of a class are objects of another class type. Composition is a has-a relation between classes. In the case of composition, use the member object name to invoke its own constructor. Let's talk about object-oriented design, or OOD, and object-oriented programming, or OOP. In a single inheritance, a derived class is inherited from a single base class. The three basic principles of OOD are as follows. Encapsulation, the ability to combine data and operations on that data in a single unit. Inheritance, the ability to create new objects, classes, from existing objects, classes. Polymorphism, the ability to use the same expression to denote different operations. In OOD, a class is a fundamental entity. In structured programming, a function is a fundamental entity. In OOD, a program is a collection of interacting objects. C++ also provides parametric polymorphism. C++ also provides parametric polymorphism. The hardest part in OOD is to identify the classes and objects. We begin with a description of the problem and then identify all of the nouns and verbs. We choose our classes from the list of nouns and we choose our operations from the list of verbs and how they interact with each other. That is all we have for this chapter. If you found this video useful, please hit the like button, leave a comment, and subscribe to the channel. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right. And I'll see y'all next time. Thanks for watching.